So in the last class, good evening, Shubham. So
Yes.
in the last class, we have actually finished the chapter first. So in today's session, we are going to see what? We are going to start combinational circuit. Okay. I know I have given few questions. So let us first solve that. And then we are going to start this new chapter. So have you guys solved? So have you solved this question? I have actually sent you the slides. So the link I have already shared with you guys. So anybody tried this question? You forgot to revise. Oh no. So then it's very bad. Since I told you guys to make your notes properly and to revise. Chandana, is this your first class? Since I am seeing, can we discuss the numerical tomorrow, sir? No, sir. I haven't seen you in the class. Okay, it's your second class. So I might not have observed. Okay, so it's okay. Can we discuss the numerical tomorrow? Okay, so already this thing is present in the Google Drive, this slide. Okay, you guys can copy it. Okay, you guys can, sorry, download it and you can see it. Okay, so today I am a little bit going sick means. Okay, then today let us then start with combinational circuit. Yes, so Shubham, Raju. So Raju, is this your first class or have you attended the last classes also? So Chandana, you are from which branch? Okay. Okay, so I haven't started the screen sharing. I'm very sorry. Yeah. So now then let us start what? Let us start combinational circuit. Okay. So now what do we mean by combinational circuit? Okay. Look at the combination circuit. So combination circuit is basically a circuit in which we connect different gates to form a circuit. Okay, we connect different gates to make a circuit that serves a purpose. Okay, that serves a purpose. For example, like multiplexer, demultiplexer, adder, means half adder, full adder, subtractor. Okay, like this there are lot of combinational circuits that we have. We are going to study them one by one. Okay, so now what is this combinational circuit? I told you that it is basically a circuit that is formed using different logic gates. Okay, so we know what in a logic gate, suppose this is my AND gate. So if this AND gate is ideal, ideal means what? There is no propagation delay. So if I apply input A and B, so A can be anything, it can be 0, B can be 1. So if I apply this, sorry, if I apply this input at t equal to 0, then immediately my output will be also 0 at t equal to 0. Now assume at t equal to 1 second, I am applying both the inputs at 1. So immediately at t equal to 1 second, your output will jump from 0 to 1. Okay, 0 to 1. So Raju, you are from which stream? Is this your first class? CSE. I haven't seen you guys. Why I always observe, I always notice, but okay, so that is okay. So that is good also. So the first chapter, okay, so that was, just wait a minute. So the first chapter, everything is recorded. Okay, you can watch the recording, and if you guys have any doubt, So you can just ask me in the group. Okay, I will try to clear it. Okay, both Chandana and Raju. Okay, so Chandana, yours is second class, so I guess you might have missed few classes. So watch all the recordings, and if you guys have any doubt, you can just ask me. Okay. Yes. So I was telling what? I was telling that in your combinational circuit, basically the output, the present output, I should be telling, present output depends on the present input. So if you have studied signal and system, so you might be knowing that such kind of system is known as static system. Static system means what? That a system does not have memory. Now what do we mean by that? Does not have memory means that your present output, it is your function of present input. Okay, your present output is a function of present input. So this is what combinational circuit is, your static system. Now another type of system we have, that is your dynamic system. So this we are going to see in the next chapter when we study sequential circuit. So dynamic system is basically what? It is memory system. So we will talk about this later. At the moment, you can just note this much down that dynamic systems are memory system. Okay, memory system, and this we are going to study in your sequential circuits. Okay. So this is what third point I have written, that it is a memoryless circuit. Why? Because your present output depends on your present input. There is no provision for storing the past outputs. Okay, past output in memory system, basically the present output is a function of present input as well as past output. So for storing the past output, basically we need to have a memory element. So we are going to see those memory element can be a latch, it can be a flip flop. So we will see that in the next chapter. Okay. So now the first circuit that we have in the combinational circuit, it is what? It is an adder. So an adder, it is of two types, half adder and full adder. So first we are going to see what? First we are going to see half adder. Okay, half adder. So half adder is what? It is basically a combinational circuit which is used to add two 1-bit number. Okay, two 1-bit number means what? Like if we have this number is A, this number is B, we want to add it. So 1 plus 0 will be 1, carry is 0. Similarly, we can add 0, 1. So sum will be 1, carry will be 0. Similarly, we can add 1, 1. So sum will be 0, carry will be 1. Now remember that in Boolean algebra, I told you 1 plus 1 corresponds to 1. But this is Boolean arithmetic. So 1 plus 1 is basically what? It is 2. And 2 corresponds to 1, 0 in binary. So basically this sum is 0 and this 1 is carry. Okay. So now let us see what is this half adder. So basically in our calculator and all the places we have actually full adder, but full adder is constructed using half adder. Okay. So look very carefully what is half adder. So a half adder has what? It has two inputs to add two 1-bit number, and it has two outputs. One of the output is sum and another output is carry. So let us see what is this. So the combination and A and B can be like this. Okay. So these are your input and this is your output. So when we add 0 with 0, sum will be 0, carry will be also 0. When we add 0 and 1, sum will be 1, carry will be 0. When we add 1 with 0, sum will be 1, carry will be 0. When we add 1 with 1, so sum will be 0, carry will be 1. Okay, so this is Boolean arithmetic. This is Boolean arithmetic. Basically, we are adding numbers. Okay. So now, if I want to write the expression of S, okay, if I want to write the expression of S in terms of inputs or AB, you can see I can write S as A XOR with B, because this is actually what? This S is truth table of your XOR gate, and this C, I can write it like what? Basically, at this place only we have a min term, so that will be AB. Now you can even write the max terms also. It's up to you. If you want to write max term, you will get the same expression. Okay, you will get the same expression. So you can see over here that we got what? Sum as A XOR B and C as A dot B. Okay. Okay, fine. So now look very carefully. Okay, look very carefully. We have this what? We have your sum and carry. So now let us try to make the circuit diagram. So what did we get? Sum is equal to A XOR B and carry is equal to A dot B. Okay. So if I draw the circuit diagram very quickly, so this will be what? This is sum. So this is A XOR with B, and this is what? AND gate. So this is A dot B. So this is the circuit diagram of your half adder. Okay, half adder. Now let us see what is a full adder. So full adder, basically, see here, means last time I had drawn. So whenever this case arises, okay, whenever this case arises, so here we were doing what? We were adding two 1-bit number. But suppose if we have something like this, so now you can see what? We are actually adding two 2-bit number. We are adding two 2-bit numbers. Okay. So let me take it in full adder page only. So when we do this, so let me assume that this part is implemented by half adder and this part is also implemented by half adder. Means what I am trying to say, let us assume this number is A, this number is B. So A is in this form, A1 A0, and B is in this form, B1 B0. Now suppose if I want to add this two, okay, if I want to add the LSB bit, what will happen? 1 plus 1 is 0, carry is 1. Now you can see what? That there means in this MSB position, I need to add 3 1-bit number along with this input carry. So what I am telling, that in this position, in the subsequent next position to LSB, you can see what I require. I require to add 3 1-bit number, and the third bit is what? This is your input carry. So basically a full adder, it does this job. So it is used to add 3 1-bit number, or you can say 2 1-bit number, 2 1-bit number along with input carry. So this is done by what? This is done by full adder. Okay, so this is the basic motivation why we require full adder, because always in addition we have carry and in subtraction we need to do borrow sometime. Okay, so let us see. Okay, let it be over here. So you can see here also we have 3 input. So 3 inputs are what? The numbers, 2 1-bit number along with an input carry, and we have sum and carry. Okay, so now let us do what? Let us try to make the truth table. Okay, truth table. So truth table, let me make. So this is the circuit representation of full adder. I forgot to tell you. And this is the circuit representation of half adder. So truth table if I want to draw. So A, B, C. Sum, carry. So let us write all the combinations. Okay, I wanted to ask you one thing. How many of you guys are working? Okay, so Shubham, when do you get, means when does your, is it online? Means I am just, means this work from home going on or what, you have to go to your office? So it's online. So when do you get free usually? So when do you, means just one more month to go, it's okay. So when do you guys are free actually in the evening? See, because I had skipped classes for 1 week after 8:30 only. Okay, so we can't start the class from 8:30. It's okay then. So from, means from the next session onward, we are going to start the class exactly at 9 and we are going to go till 11:30. Okay. So 2.5 hour class we are going to have. Okay, because I have skipped 1 week session due to my sickness. Okay. So from the next class we are going to have. So do your dinner and then come to class. In between I will give you like 5-10 minutes break. Okay. After 1.5 hour I will give 5 minute break. Okay. So you can freshen up yourself a little bit. So then it will be okay. Okay, fine. So now let us see the sum. So here you can see what? So if I add 0, 0, 0, sum will be 0, carry will be 0. Over here, A, B, C, so sum will be 1, carry will be 0. Basically, what do we mean by this? So A is 0, B is 0, and C in is 1. So if we add this 3, so what? So sum will be 1 and input carry is 0, you can see. Okay, so that is what I am writing. So here also 1, 0. Here sum will be 0, carry will be 1. Here sum 1, carry 0. Here sum 0, sorry, yes, sum 0, carry 1. Here also sum 0, carry 1. Here sum will be 1, carry will be also 1. Okay. So now let us make the K map for sum and carry and see what is the expression for S and C. So I should be writing this as C out because this is carry out, this is carry in. And everybody should revise before coming to the class. Okay, it is necessary that you revise or else you won't be understanding because I will be taking help of the previous sessions also. So first I am writing S. So S is what you can see at this place, and this place and this place it is 1. So this corresponds to 1, 2, 4, 7. So 1, 2, 4, 7. Okay. So already I have told you that such kind of K map is basically that of XOR for a 3 variable XOR. So this will be A XOR B XOR C in. Okay, we have discussed this in K map. Now let us try to write about C out. So we can see where is it one? Over here, 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 and here. So this place is 3, 5, 6, 7. So 3, 5, 6, 7. Okay, so this 4 places it is 1. So let us make groups. So you can see one of the group of 2 is this, another group of 2 is this, and one more group of 2 is this. So if I write the expression, minimized expression for this, so this will be what? B C in plus A, and over here this is C in plus A, and over here we have B, AB. Okay, so this I can write as AB plus B, oh sorry, C in A plus B. Okay, I can write it like this. Tell me if this is clear or not. Is this clear up to this point? 1, 3, 5, 6, 7. Is this clear? Okay, fine. Now there is one more way in which I can write this. Okay, this carry out. For some this is the expression, but look at carry out, how I am going to write. So it is 3, 5, 6, 7. Okay, so C out is what? 3, 5, 6, 7. So I can write it, means C out in terms of A, B and C in I am going to write. So 3 will be written as A complement B, C in. 5 will be written as A, B, C in, like this. 6 will be A, B, C in complement, and 7 will be A, B, C in. Okay, I can write it like this. Now look very carefully. I can take this two term and write it like C in common A complement B plus A, B complement, and over here I can take AB common, and this is what? This is C in, sorry, C in, C in complement. So this is what? A XOR B, C in plus AB. So this is actually equal to AB plus A plus B, C in, which this we have got using the SOP, okay, using K-map, and this we got using minimizing this expression. So both of them are correct for C out. Okay, so this we got using your K-map, and this one we got using what? We got using the minimizing the expressions. Is this clear? And yes, guys, don't join the class late. Okay, I will suggest that, because if you join late, then you would again need to visit the session, so that will be a waste of your time. Okay, so don't do that. Is this clear up to this point? Everything clear? Okay, fine. Now we have what? We have the circuit diagram. So how do we actually make this? So for some we got it as A XOR B XOR C in, and C out. Raju, no need to write yes sir. Okay, yes, it's, you don't need to write. Just write Y or N. Whenever I ask if you have understood or not, you can just write Y or N. And C out we got A XOR B, C in plus AB. Okay. So now we need to construct this. So we can construct it using two half adder. Look how. Carry over here, it will be what? Because your input is Cin and this is A XOR B. So your carry will be what? It will be Cin dot A XOR B. So here you can see basically this is actually odd. Okay. So I need to have one OR gate over here. I need to place one OR gate. Okay. So this will be your Cout. Okay, this will be your Cout, where Cout is A XOR B Cin plus AB. So you can see Cin A XOR B and AB is coming. So you can see you can implement the circuit using two half adder and one OR gate. You can even break this circuit of half adder in your consecutive NOR gate and your AND gate, like I have done. Okay, so all those things you can do. I am not doing. I have just shown you the simple circuit diagram of your adder. See, now I know that basically there is this ripple carry adder, look ahead carry adder. So that we will do in the next class. Okay, because I need some concept from today's class. So that is why today I am discussing this. In the next class that we have on Thursday, we are going to do that. Okay, look ahead carry adder, ripple carry adder. Okay, 4-bit binary parallel adder. We are going to see all those things. So now the next is what we have is half subtractor. So what does this half subtractor do basically? Half subtractor circuit is basically used to find the difference between two 1-bit number. Like if I do 1 minus 0, so this will be what? 1 borrow. So here borrow is there, okay, not carry. Like if you want to do 9 minus 6, so this will be 3. But if you want to do 6 minus 9, so here what you do? You take borrow 1 and then you do, okay, you take, this is borrow, you take borrow 1 and what you do? Basically you write this is minus, okay, so sorry. So what we do means, even I have forgotten to do like this, minus 3. So we take borrow, even I forgot how to take this borrow in your decimal number, because usually we don't do like this anymore. So 6 minus 9. So how do we actually do? I forgot. So this is coming out to be no. Okay, let me take a 2-digit number. Means now these days these are all 1 becomes 0. No, I am asking how do we do actually, means we have learned this in your class 6-7, but I am not remembering what to do. I have forgotten. Okay, so usually we don't do such kind of subtraction anymore. So 36, 56. Okay, so what we do basically, 2, this becomes 2 and this becomes 15. So this is 9 and we do what? Means I am not remembering. Yes, so we know this 9 minus 6 is 3, but I am asking what is this borrow thing. Okay, borrow I have forgotten. Means we all know what will be 35 minus 56, that is minus your 11, is minus 21. Okay, but actually what is the mathematics, that I am not able to recollect. Means if we want to do this, so what we do, we take 1 over here and we have 2 over here, so that is 9. And what do we do over here? This I am forgetting. No, it is not like that. I am not able to recollect, means I have forgotten the basic maths. Okay, so I am not able to recollect. So what was it? Let me just pause the video. But actually I have forgotten. Okay, because sometimes what happens, we are so much into means advanced thing, we forget the basics. Okay, we forget the basics, so it's okay, let us not ponder over this. So look over here, what is basically happening is we have two 1-bit number. Okay, so if we do borrow concept of borrow, then we might be wasting time. Okay, so it's okay. So difference and borrow. So the possible combinations can be 0 0, 0 1, 1 0, and 1 1. Okay. Yes, if we want to solve means like this 27 minus 36. I guess this we can solve using 9's complement or even 10's complement. Like 36 in 9's complement will be what? It will be 36 9. Okay. So this will be 3 and this will be 6. Okay, this will be 6. So this is 1's complement basically. So if we add now 27 and 63, what do we get? So this is 10, 1, 6, 2, 8, 9. So this is what 6 9 90 we are getting. Okay, 90 we are getting, but even I am forgetting these all things. Simple mathematics. What is happening? So 90 we get. I am not able to recollect things. Okay, today. So what was it? I forgot completely. Subtraction. I have only shown you guys using this 9's complement, and today I am not able to recollect. So minus 36. So this will be 99 minus 36, 663, and then we add 27 to it. So that is 90. So 90, but this is negative number, so we need to take complements once again. So this will be 9, 0, 9. This is okay, means negative sign needs to be placed at the left. 99 minus 90, yes, so that is 9, yes. So that is what I have also done. So this is basically what we can solve it using 9's complement also. So okay, let me take this concept of borrow in the next class. I will try to understand, okay, and I will tell you guys. But today I am not able to remember what is this borrow. Concept of borrow means mathematically I forgot. Okay, so 0 minus 0, difference will be 0, borrow will be 0. Now look, if I subtract 0 from 1, okay, so what I need to do, I need to take a borrow. Okay, I need to take a borrow. So this is your borrow, and I will place it over here. So 1 minus 1 will be 0, and this will be borrow will be 1. So difference is what? Difference, sorry. So difference will be 1, and even borrow will be what? Borrow will be 1. Okay. Now if I do 1 minus 0, so your difference will be 1, borrow will be 0. Now if I do 1 minus 1, so difference is 0, borrow will be also 0. Now if I write the expression for difference, so difference will be what? Again you can see it is basically A XOR B, and borrow is what? Borrow you can see it is A bar B. So this we get when it is A minus B. But if I ask you what will happen if I do B minus A? So for B minus A, if you solve it, you will be again seeing that difference will be A XOR B only. But borrow, it will happen. When do we get borrow? When your B is less than A. So here this is your digital numbers as. So when will this happen? When B is 0, A is 1. So at this time you will get borrow. So this is basically what? This is AB complement. So at this time you will have borrow. So remember, this is for A minus B, and this is for B minus A. So this is your half subtractor. Okay, this is your half subtractor. Now I am not drawing the circuit diagram. Okay, you can draw it yourself also. So the next is what we have is full subtractor. So in full subtractor, what we have? We have basically two 1-bit number along with an input borrow. Okay, along with an input borrow that we have. So here also we have two output, that is difference and borrow out. So now let us draw the truth table for this also. Okay, so what I want you guys to do, quickly tell me what will be difference over here and what will be borrow out, output borrow. Tell me quickly what will be the difference and borrow over here. Means expression. Tell me expression. Don't tell me this one, okay? So again, if you make the truth table, so hopefully you might have get the same thing. So this is 1, 2, 3, 4, 7. 1, 2, 4, 7. So 1, 2, 4, 7. Again, you can see what? That this is the K map for XOR. Okay, K map for XOR. So this is K map for A XOR B XOR C in. Sorry, I have written C in over here. So this should be B in. Okay, B in, not C in, B in. So A XOR B XOR B in. And what about the B out? So you can see this is 1, 2, 3. So 1, 2, 3, and this is your 7. So like this we have. So one group will be like this, another group like this, and this will be one more group. So this will be what? So this will be B in plus A bar, and this will be B in plus this will be A bar, and over here that will be B. Okay, so this you get, so you can even write it like B in plus A bar common B plus B in. You can write it like this also. What B in XOR A? Yes, Chandana, this is for this one. How many of you got for the B out? B out? Anybody? Am I audible properly? Because there is some net sign showing on my tablet, so that means my net speed is not that good. So this is what? This is for your full subtractor. We have calculated this for, means look, again I have written C in over here. This is not C in, I am very sorry. This will be B in. So I have done this for A minus B in. This I have solved. Now leave some space. Your homework will be to calculate for B minus A minus B in. For this one you need to calculate. So you will be seeing that this sum, means your difference will be the same, but for this one your expression for B out, it will change. So I want you guys to solve it, okay, and tell me in next session. Okay. Okay. So with this we finish this full subtractor, half subtractor. Questions are not asked from this much. Okay, once it has been asked what is the cout expression for your full subtractor, it has been asked, but none of the concept are used, means asked that much. Usually they ask about carry ahead look adder. Okay, look ahead carry adder they ask, and they ask this 4-bit binary parallel adder or serial adder also they ask. Okay, so that we will do in the next class, because I need some of the concept actually to solve the questions. Okay. Okay, so today we are going to do what? We are going to see this multiplexer. We are going to cover the concept of multiplexer, and we are going to see few questions of multiplexer also, because maximum questions, okay, maximum questions has been asked from the multiplexer topic only. Okay, so let us see what is a multiplexer. So can anyone tell me what is a multiplexer? Now don't read over here and tell me. Just tell me, what do you understand by a multiplexer? Anyone?
So it takes several inputs and provide
Okay.
only one selected output.
Okay. So
So
on what basis does it select the input? Yes. Tell me.
I don't know what's basic it select. I just know it selects one
No,
single.
means there is no random, means there is no random motivation for the mux to select a input. Okay. Suppose
Yes.
like there is this input. Okay. So there might be some rule or something that by following which it selects input and output. Okay. So multiplexer, you can think of it like a switch. Okay, think of it like a switch. So assume that over in this place I have inputs. Okay, these are known as my what? These are my multiple inputs. Multiple inputs. Okay, here I can see this is one input line, second input line. Like this, there can be n inputs. Okay, n inputs there can be. Output, there is just one single output. So basically what mux does, that it connects one of the input to output. Like we can connect this input to output. So basically this input will be flowing over to the output, or this input can be connected to the output, or even this input can be connected to the output. Nth input. Okay, this is nth. This is first input. This is second input. Like this we can connect any one of the input. Now, how do we decide actually to which input should we connect? We decide it with the help of selection line. Okay, selection line. So what does this selection line do? Basically, the selection line selects which input should pass to your output, or basically it selects which input and output should be, means which input should be connected to the output. Now, if there are n inputs, so the selection lines will be log base 2n, or if there are 2 to the power n inputs, your selection line will be n. Okay. So selection lines are what? Selection lines are basically your lines with the help of which we select which input should be connected to your output. So this is also known as data selector. Why data selector? Because in this inputs we have data. So we select which data should be transmitted to the output. So that is why your multiplexer, another name is what? In communication and signal processing, it is also known as data selector. Multiplexer, what I have written, multiplexer is a device that allows digital information from several sources to be routed to a single line for transmission. So this is your textbook definition. So next is what? It has basically several input line and a single output line. There are 2 to the power n input line and n selection line and one output. So I will be now explaining that why, if we have n selection lines, we can basically have 2 to the power n inputs. So that let me explain. So now the first example is what? 2 cross 1 mux. Now this selection line, this everything is binary. So this is a 2 cross 1 mux. Why? Because here we have 2 input and one output. It's not like that we have one selection line for that. No, we have two input and we have one output. So basically everything is binary over here. So this selection line, it can have how many values? It can be either 0 or it can be 1. So S has possibly two states. Okay, it has possibly two states. One of them will be what? It will be S bar, because I told you what? It can take values from 0 and 1. So 0 corresponds to S bar in positive logic and 1 corresponds to S. So whenever we take 0, what happens? This I naught line gets selected to your output. This is O. This is not 0. This is O. O corresponds to output. Okay. Or you can even write it as Y. No issues. You can write it as Y. So whenever S is 0, then I naught will be connected to Y. And when S is 1, I1 will be connected. So depending on the values of selection line, see here there is only one selection line. One selection line means what? There is only one variable. So if there is only one variable, we have possibly two states. So two states can correspond or link only two input. So how do we write the expression? It can be like y is equal to, whenever it is S complement, I naught will be selected. Now I naught can be anything. I naught can be 0, it can be 1, it can be a string of binary number, it can be anything. Okay, it can be anything in binary. I am not defining that. I am generalized, in a generalized way I am defining that it is I naught. Or what will be the other case? If S is equal to 1, so that corresponds to S, then I1 will be at your output. So this is what I have written. So you can also write it like this. Output will be, when it is S bar, I naught will be selected, or when it is S, I1 will be selected. So this is what I have written in Boolean expression. Okay, this is what is written in your Boolean expression. Just give me a minute. Yes. So this is what is written in Boolean expression. Okay. Now let me ask you, can you draw the circuit diagram for this? Circuit diagram? Okay, truth table. Let me show you the truth table first. So truth table can be what? Just give me a minute once again. While teaching, if I find any noise, it distracts me actually. So look, truth table will be what? So S and Y. See, when S is 0, output will be I naught. When S is 1, output will be I1. So you can write it like this. Now if you want to implement it using your logic gates, how will you do? So basically, look over here, you have a selection line S and S naught. This is S, this will be S complement. So whenever S complement is there, I naught will be connected. So I can make it like this. This will be what? You can see this is S complement. So the output of this will be what? It will be S complement I naught, and output of this will be what? S. This will be S into I1. Now this needs to be passed through an OR gate. So this will be what? This will be your Y. So this is your circuit diagram for a 2 cross 1 mux. Okay. Now depending on the selection line, it will be what? Basically, which of the output will be selected. Assume if S is 1. If S is 1, what will happen? This line will be high, this line will be low. So if this is low, so over here this will be 0. Why? Because one of the input of this AND gate is 0. So this will be 0. Now look over here. So this is 1. Okay. So over here 1 is there. And from here I1. So this will be S dot I1. And this Y will be what? S dot I1. Okay. So this is what? This is a 2 cross 1 mux. Now similarly, let us see what is a 4 cross 1 mux. So in 4 cross 1 mux, we have basically 4 input and 1 output. Okay, 4 input, 1 output. Now if you see over here, basically there are two selection lines, S1 and S0. So if nothing is said about selection line, this will be MSB, this will be LSB. So if you see, there are two variables in selection line. They are what? S1 and S0. So basically, if we have two variables in selection line, so in binary with two variables, we can represent 4 numbers, or here we will be writing it as 4 inputs we can represent or select using two pair of selection line. Okay, using a pair of selection line, we can select 4 input. So how can we do that? So the combination of selection line can be 0 0, or it can be 0 1, or it can be 1 0, or it can be 1 1. See, in question it will be given that which of the selection line is MSB or LSB. If nothing is given, the selection line that has a higher number in the subscript, you are going to take it as MSB. So if you take 0 0, so this corresponds to what? This corresponds to decimal 0. So I0 will be selected, I0. If your selection line is 0 1, so I1 will be selected and pass through your output. If it is 1 0, that corresponds to decimal 2, so I2 will be selected. If it is 1 1, this corresponds to 3, so I3 will be selected. Now if you want to write the Boolean expression for this, so how can we write? Y will be equal to, see, in Boolean 0 correspond to complement form, so I can write it as S1 complement S0 complement I0 plus S1 complement S0 I1 plus S1 S0 complement I2 plus S1 S0 I3. Okay, I can write it like this. Can we make the circuit diagram for this one? Can we make for a 4 cross 1 multiplexer? So it's okay. You can do it as your homework. Okay, it is not that difficult. It will be time consuming, so that is why I don't want to do it. Okay, you can do it yourself also. So this is your expression for what? This is your expression for 4 cross 1 mux. Now the last thing is what? 8 cross 1 mux. So in 8 cross 1 mux, we have input 8, output 1. So now if I want to select 8 number of inputs, now you can even have like 5 inputs, okay, 5 input, but the number of input lines, it will be in the power of 2 only, like 2, 4, 8, 16, 32. Now out of this 8, you can select 5. You can do what? You can make 0 or ground the remaining 3 inputs which you don't require. That you can do, but input lines will be always to the power of 2. Okay, so if I have 8 input lines, for selecting 8 input line, I require how many selection line? I require minimum 3 selection lines. Why? Because with using 3 selection line, I can select from 0 to 7. So here also, if I want to write your output, so directly I am writing without drawing the truth table. So here S2 corresponds to MSB and S0 corresponds to LSB. So if I want to write the direct expression, so that will be Y is equal to S1, S2, S1, S0 complement I0 plus S2, S1, S0 I1 plus S2, S1, S0 I2 I3 plus S2, S1 complement S0 complement I4 plus S2, S1 complement S0 I5 plus S2, S1, S0 complement I6, and last will be S2, S1, S0 I7. Okay, so now depending on whatever is the combination, like if you take 0 1 0, if you do 0 1 0, what will happen in this expression? Only one of the min term will be selected. So which of that? So this one, where is it? Yes, this one. So this one will correspond to 1, and depending on whatever is your output, that I2 channel will be transmitted to your output. Okay, is this clear? Is this clear? Everyone, tell me, any doubts? So today everyone is present. Why in the last class means most of you were absent? So the last class, I guess it was on Monday. No, Monday I had that class. So Friday I had a class with you guys and you guys were absent. Why so? So don't miss the class. Okay, then what happens? It is actually what? Then your this work, it builds up. Okay, it piles up. So then usually you will be skipping live sessions, you will be watching recording only. So try to avoid skipping classes. Okay, if it is not that much required. Okay, so now multiplexer is what? It can be used as a universal circuit or universal combinational circuit. Why? Because we can construct the 3 basic gate using multiplexer. How? So let us see one by one. So first, let us implement NOT function using a 2 cross 1 mux. So look, what should be, see, selection lines, I always give the variable. So if I give a over here, what should be the input so that I get y is equal to a complement? So you can see, if I put I0 as 1 and I1 as 0, what will I get if I want to write y? So y will be equal to a complement, means if I write it like this, s complement I0 plus s I1. So s comp means s is what? It is equal to a. So this will be a complement into I0. I0 I have already selected as 1. And s means what? That will be a dot I1 is already 0. So this comes out to be a complement. So y comes out to be a complement. Okay. So this is how you implement NOT gate using a 2 cross 1. Now I want you to implement AND gate. How are you going to implement AND gate? using a 2 cross 1 mux. So do it very quickly and tell me what should be selection line, what should be I0 and I1.
So,
Yes, tell me.
show me the last slide, sir. I have to note it down. Yes.
Yes, so tell me what will be the input and selection lines over here so that you get AB. See, you require AB, okay, AB. So one thing is fixed, you can take selection line as A, okay, take selection line as A. So if you write Y, so this will be what? A complement I0 plus A I1. So you require what? AB. So if I take B over here and 0 over here, so this will be what? A complement dot 0 plus A dot B. So that is AB. Okay, this is AB. So this is the input combination for getting AND gate. Is this clear? Tell me. Now you might be telling, sir, why can't we take like this? You can take, it is up to you. It is up to you, whatever you want to do. Okay, but then what will happen? You will get B means like this, B complement I0 plus B A. Okay, this you will get. Here B will be your MSB and A will be LSB. So MSB, LSB in multiplexer question, any place. See, I will show you few questions of multiplexer. It will be actually told to you like over here in this question. Even if it is not mentioned in the option, you can see it is A, B, C. Okay. And over here also you can see S2 corresponds to A, S1 corresponds to B, S0 to C. So I have already told you, if nothing is mentioned, the selection line that has the higher subscript, you are going to write it as MSB, and the lowest subscript will be your what? It will be your LSB. Okay. Okay. So the next is what? A plus B, that is OR gate. I want you to do this. I want every one of you to try. Okay. So tell me, what are we going to take?
So,
Yes.
no, sir. I think I'm wrong.
Yes. Tell me quickly. See, this was one of my interview question in Tata Powers when I was in IIT. At that time, they asked me what will be OR gate. So this was a quick fire round, and you need to think very quickly. Okay, very quickly. So if you see, look over here. If you take I0 as 1 and I1 as B, what will happen? Your expression will be A bar dot 1 plus AB. So this will be A bar plus AB. Now use distributive property. So this will be A complement A plus AB. So this comes out to be what? A plus B. That is your OR gate. Okay, OR gate. Is this clear, everyone? Tell me. Clear, everyone? Fine. Now I want you to perform NOR operation. NOR operation, tell me. See, selection line, I am always taking it as A. So what can we do over here? Very simple. If I take I0 as what? If I take I0 as B complement and I1 as 0. So this will be what? This will be A complement dot B complement plus A dot 0. So this will be A B whole complement using De Morgan's rule. But tell me one thing, for implementing this NOR gate, if I want to implement it using 2 cross 1 mux, listen very carefully. If I want to implement NOR operation using 2 cross 1 mux, how many 2 cross 1 mux do I require for implementing this? How many 2 cross 1 mux will I require to implement this function? How is it 1? How is it 1? See, you always have A, B, normal variables, it is readily available. But complemented variable, it is not readily available. Look at the last example I had taken. See, normal variable was readily available, but to take the complement, I had to introduce one inverter. Okay, I had to introduce one inverter. So whenever there is a complemented variable, that means it has been generated using an inverter. So here basically I have what? I have B complement. So I have A and B present, but B complement I don't have. So for generating this B complement, I require 2 cross 1 mux. In the last to last slide, we have seen what? How to make NOT gate using 2 cross 1 mux. So this B complement will require 1 mux, and for implementing this NOR gate, I will be requiring 1 more mux. So in total, 2 cross 1 mux is required to implement what? To implement A NOR B. Or you can even say 2 cross 1 mux and 1 inverter. Tell me, is this clear everyone? Why 1 is wrong? So I asked you guys that tell me what will be the total number of 2 cross 1 mux so that we can construct this function. Okay? Okay, fine. Let us move forward. Now we want to construct NAND operation. So very quickly tell me. Okay, so we have this. So what should we take? See, 0B. So if you take 0B, what will happen? So this will be A complement dot 0 plus AB. So where am I getting complement over here? This will be 0. So this is AB. B complement 0. Okay. Next is what? Shubham is telling me to take B complement and 0. So B complement and 0. So if we take B complement 0, so this will be A complement B complement plus A dot 0. So again this will be A nor B. So this was the last case, I guess. Last case. So I have to take the same case once again. So look very carefully what I take. So let us take 1 over here. If you take 1, what will happen? This will be A complement dot B complement plus A. Okay, plus A. Again use distributive property. So if you use distributive property, so this will be okay. So sorry. One B complement. Now if you solve this, this will be A complement dot 1 plus A dot B complement. Now solve this using distributive property. So A complement plus A complement plus B complement. So this will be 1 dot A dot B whole complement, or this is A dot B whole complement. So 1 B complement is your correct answer. So here also you can say that 2 cross 1 mux is required for constructing this NAND operation. Okay, NAND operation. Now similarly for this one, this is very simple. You want to construct A XOR B. So this is very simple. Okay, why? You take B over here and B complement over here. So Y will be what? It will be A complement B plus AB complement. So that will be A XOR B. Similarly, you can even do XNOR. So that is also very simple. Just take B complement over here and A over here. So you will be getting what? A complement B complement plus AB. So that is A XNOR B. Okay, A XNOR B. Now, look over here. I am making one statement. Listen very carefully. For constructing, see, basically, if I am able to draw NOR NAND, that means I can make any of the any of the Boolean expression, because why? NAND and NOR gate, they are universal gate, and even I am able to do what? I am able to construct your basic gate using this 2 cross 1 mux. So that means what? I can implement some of the two variable Boolean expression using 2 cross 1 mux. But for implementing all of two variable Boolean expression, I require how many mux? I require minimum 2 cross 1 mux or 1 2 cross 1 mux and 1 inverter. Do you agree to this two statement or not? Everyone tell me yes or no. Everyone tell me. So do you agree to this or not? Just now I have shown you that some of the two variable Boolean expression can be constructed using a single 2 cross 1 mux. Okay, using 2 cross 1 mux. But all of the two variable Boolean expression like A, like this expression also I can make, even this expression I can make. For such kind of expression, I require minimum 2 mux or 1 inverter and 1 mux, 2 cross 1 mux. Are you people understanding what I am trying to say? See, I told you, using two variable, I can construct 16 Boolean expression. Why? 2 to the power 2 to the power 2. So that is 16. All of the 16 variable can be constructed using either 2 cross 1 mux or a single 2 cross 1 mux and 1 inverter. But when I use just a single mux out of this 16, some of the functions can only be implemented due to the fact that I need one more mux to create one complemented variable. Even should be V. What I1 should be V? Oh, yes. Yes. So did we understand this or not? That some of the two variable Boolean expression can be constructed using a single 2 cross 1 mux, whereas all the Boolean variables of two variable can be constructed using a 2 cross 1 mux, means 2 cross 1 mux, okay, or a single 2 cross 1 mux along with an inverter. Did we get this point? Because I will show you one direct question in gate. Okay, in gate. Okay, fine. Now look, I want to implement like whatever we have seen, A complement AB, A plus B, A plus B whole complement, A XOR B, A XOR B using a 4 cross 1 mux. Okay, using a 4 cross 1 mux. So look very carefully. If I want to implement an inverter, I can do so. Okay, I can do so. Suppose I want to construct this. Okay, I want to construct this function. So how can I do it? Okay, sorry. So this is what? This is S1, this is S0. So always remember, I will place the variables in selection line. So if this is AB, so I want to construct A XOR B. So that means what? If I write Y over here, so Y will be what? Y will be equal to A bar B bar I0 plus A bar B I1 plus A B bar I2 plus AB I3. So if I want A XOR B, simply what I will do, I will take I0 and I3 as 0 and I1 I2 as 1. So then we will get what? This will be 0 because I0 is 0 and this term will be also 0 because I3 is 0. So remaining will be A complement B plus AB complement. Similarly, if I want XNOR, so what I can do? I can simply make this as 1 0 0 1. If I want A complement B, means NAND operation, so NAND operation, this will be what? If I take this, I will be getting NAND. Okay, I will be getting NAND if I take this. If I want NOR, I can take the input combinations as okay. If I want NOR, so I can take it like this. What will I get? Y will be equal to A complement B complement into 1 and remaining all will be 0. So this will be A plus B whole complement. So what are we noting over here? That any of the two variable Boolean expression, that means out of this 16 Boolean expression that we are constructing using two variable, 16 Boolean expression constructed using AB, a single 4 cross 1 mux can implement it. A single 4 cross 1 mux can implement it. Is this clear? Tell me. Is this clear? Tell me if this is clear or not. Okay, if this is clear, so now let me tell you one more thing. Suppose if I have three variables A, B, C. Okay, A, B, C. So if I have three variables, that means how many functions do I have? 2 to the power 2 to the power 3. So that is 2 to the power 8. So that is 256. So I can construct this 256 using a single, I can construct sum of the function using a single 4 cross 1 mux. Okay, using a single 4 cross 1 mux, or all the 256 function using two 4 cross 1 mux. Okay, or all the functions can be constructed using one 4 cross 1 mux and an inverter. Okay, I can construct it using what? Using an inverter and one 4 cross 1 mux. Why? Because out of this, you saw just now, okay, out of this 3 variable, I can construct this any function of AB using a single 4 cross 1 mux. But for this C, I will have two more variables, that will be, one will be C, one will be C complement. So for constructing this C complement, I will be requiring one more 4 cross 1 mux, or I will be requiring, you can say even a single 2 cross 1 mux will take. Means you can either do it like this, 2 4 cross 1, or you can take 1 4 cross 1 mux and along with that 1 2 cross 1 mux. Why? Because I require one C complement. So C complement either I can construct using a 4 cross 1 mux also, or I can construct it using a 2 cross 1 mux also. Okay. So you can see what, that for constructing this 256 function, I require minimum 2 4 cross 1 mux. Okay. So now if I generalize this to n variable, any n variable can be constructed, means sum of the out, when we have n variables, so total number of function will be how many? 2 to the power 2 to the power n. Okay. So out of this, some of them can be implemented using 2 to the power n minus 1 cross 1 mux. All of them using 2 to the power n cross 1 mux, or all of them using 2 to the power n minus 1 mux, or 1 2 to the power n minus 1 mux and an inverter. Okay. So this is very important, very, very important. Tell me if you have understood this or not, everyone. Yes or no? Y or N? If you have understood, there is one direct question that I want to show you. Look over here, 2009. Even the same question was repeated in 2017 also. Okay. So solve this question and tell me what will be the answer. Which option? So this is 8 cross 1. Okay, 8 is to 1 means 8 cross 1. Someone is saying C, someone is saying D. Only two answers. Why? So look very carefully. I just now told you what? That if we have n variable, so what can we do? Sum of the functions out of this 2 to the power 2 to the power n, we can construct using 2 to the power n minus 1 cross 1 mux. Okay. So here we have n variable. So out of this, means out of this 2 to the power 2 to the power n function, so this 2 to the power n minus 1 mux can represent only some, but all of them can be represented using 2 to the power n cross 1 mux. So here you can see n is equal to 3. N is equal to 3. So if we have 8 cross 1 mux, basically all the variables, three variables, all three variables can be represented using 8 cross 1 mux. Okay. So in which of the options you can see? Option A, you can see some but not all function of 3. So this is wrong. All function of 3 variables but none of 4 variables. Now, none of 4 variables, why it will happen? See, if it is a 4 variable, so that means we have 2 to the power 2 to the power 4 functions. Okay. So that is what 2 to the power 16 total functions. So out of this, some of them can be represented using 2 to the power 4 minus 1 cross mux, but all of them can be implemented using 2 to the power 4 cross 1. So that is 16 cross 1 mux, and this is what 8 cross 1 mux. So some of them can be implemented. So this option is wrong. Option D, all functions of 4 variable, wrong. All functions of 4 variable can be represented using a 16 cross 1 mux. So that means only remaining option is option C. And what is that? All functions of 3 variable, but some, but not all of 4 variables. So this is correct. Tell me if all of you have understood this question or not. So this is one very good question. Tell me if we understood or not. So whenever they ask you, you try to break this mux in this form, 2 to the power n cross 1. Now if you break it, so all the n variables can be represented using it. Okay, all the n variables can be represented using this, but n plus 1 variable, it cannot be represented using this one. Okay, n plus 1 variable, it cannot be represented using a 2 to the power n plus 1 mux. Okay. Now next, this question solve. Very quickly I want you to solve this question. See, bubble in the input means that it is complemented. Bubbled input, okay? Complemented input. Very quickly tell me what will be the answer. See, basically they here also have given what will be the LSB, what will be the MSB. Look at the output. It is given function of A, B, C, D. That means A is MSB and D is LSB. What answer are we getting? So look over here. I will only solve. Okay, I will solve. So look, basically this will be what? F will be equal to A complement, B complement, I naught. So I naught is equal to C. Directly I am writing plus A complement B I1. So I1 is D plus A B complement I2. So I2 is what? You can see it is connected to an inverter, the C line. So that will be C complement plus last is what? You can see it is AB. Okay, AB. So this is what basically this is. You can write it like this. I3. So I3 is what? It is C complement dot D complement. Okay. So now if you see, this corresponds to minterm 0 0 cross, sorry, 0 0 1 cross. So this will be either this will be 2 or this will be 3. This corresponds to what? 0, 1 cross 1. So either this corresponds to 5, this corresponds to 7. This will be what? 1, 0, 0 cross. So either this will be 8 or this will be 9. And this is fixed. This is what? This is 12. So 2, 3, 5, 7, 8, 9, 12. 2, 3, 5, 7, 8, 9, 12. Option D is your correct answer. So Chandana has got option D. So others, why are we not getting? Okay, solve this next question. Solve the next question. What answer did we get? So these are very simple things. See, look over here. This is grounded. That means this is 0. This is passing over here. And this 0 is being converted to 1. And this 1 is shorted over here. So this is 1, 1. And this one again passing through inverter. So this is 0. So look again. This is basically what? 0 means if I want to write 0, 1, 1, 0. Now the trick is, look at this and tell me the 0, 1, 1, 0 corresponding to which truth table or to which logic gate do we get such kind of output. So whenever we have A XOR B, at that time the output of the logic gate, it looks like this. So this is basically what? This is XOR P XOR Q. P XOR Q. Now similarly, if this was 1, 0, 0, assume I am telling this is 1, 0, 0, 1. Okay, means here this was connected to 5 volt. If this was connected to 5 volt, we would have got this only. So this then corresponds to what? 1, 0, 0, 1 input to this mux. So this corresponds to which logic gate? This corresponds to A XNOR B. So at that time you would have got what? P XNOR with Q. You would have got the answer. Okay, so note both of them very quickly. When you have ground at this position, you get XOR. When you have a voltage source of 5 volt, so you will be getting XNOR. See, I am telling what? Whatever is the input over here, input to this mux, basically see what is the corresponding logic gate for this. Okay, like here in this case, in the first case, if you take this is ground, so ground corresponds to 0 in digital logic. So when I pass this through inverter, this will be 1. When I again pass 1 through inverter, this will be 0. So if I pass 1, means this will be 1, this will be 1, over here it is 0 and this is 0. So look at this input combination. So that is what? 0, 1, 1, 0. And this is I0, I1, I2, I3. So if you see, for which logic gate do you see such kind of output? Directly how to solve this question. So for P, as there is P and Q over here, so P XOR Q if you do, you will be getting your output like this. So that means this mux is actually giving you output as a P XOR Q. Now assume if in this question only, instead of this ground, you had a voltage source. So voltage source corresponds to 1 in digital logic. So when I pass it through inverter, this will be 0. Again, when I pass 0 through inverter, this will be 1. And this point will be 0, 0, 1. So now you can see input to this mux is what? 1, 0, 0, 1. So check for which logic gate your output corresponds to this. So you know what, if you have P XNOR Q, your output will be this. So then if there was your voltage source, then option C would have been your correct answer. Chandana, now is it clear? Tell me yes or no. Okay, fine. So next question, tell me very quickly. Answer D, you people are telling. Okay. So look over here. This is very simple. So this is what? This is A. This is A complement. Okay. So this F will be what? F will be B complement A complement plus B A. So that is A XNOR with B. So option D. Very simple. Now this question very quickly tell me. So I will tell you the exam approach of how to solve this question. Okay. Answer C. Okay. So look. So look over here. So why you are telling option C? So let us check if it is correct or not. So you can see I0, I2 and even I4, I5, I7, they are all 0. And this is basically a 4 variable expression that we will get. Why? Because we have ABC in the selection line and D in the input. Okay, we have D in the input. So that means what? Look, for I1 I am getting D. So when will I get I1? When it will be A complement, B complement, C, D. Okay, so I will be getting this. So this corresponds to what? This corresponds to minterm 3. So mark it over here. Next, where we get I3 we get. So I3 will be what? It will be A complement B C, and what is the input? It is D. So this corresponds to 7. Mark 1 in 7. Now next, where you see in I6. I6 it is 1. So I6, how can I represent I6? So that will be A B C complement, and this is 1. Okay, this is 1. So this will be like this. So I can write it 1 1 0 cross. So this will either correspond to 12 or this will correspond to 13. So mark this also. So now you have one group of group of 2 and one more group of 2 like this. So for this, if I write your minimized expression, so this will be what? It will be A complement CD plus, for this one it will be AB and over here C complement. So which option do you see? A complement CD, A, B, C complement. So option C is correct. Directly like this you can solve question. No need of writing A complement, B complement, C complement dot 0 plus A complement, B complement, C, D, like this. You need to write 8 min terms. No required. It's not required. Why? Because most of them are 0. So such kind of question are usually given to pass your time in exam. Okay. If you write like this and then you solve making K map, it will take you very, very long, like 2 to 3 minutes. But directly if you solve, it will take you like 30 seconds. Okay. So this question, tell me. Answers. This is very, very simple question. Very, very simple. Within 1 second, you can solve this question. Look very carefully. Once again, look. What is the input to this mux? 0110. So 0110. This corresponds to the output of XOR gate. So you can write over here, this is A XOR B. Now again look, this input is A XOR B, or you can simply assume it to be this input A XOR B as X. Once again look, again this is 0110. So that means what? This is X XOR with C, and X is already what? A XOR B XOR C. So this is what we know, A XOR B XOR C, it corresponds to minterm 1, 2, 4, 7. So 1 will be written as A bar, B bar, C. So where do you see, in which option do you see A bar, B bar, C? Means have I done something wrong? 1, 2, 4, 7. 0, 1, 2, 4, 7. Yes, 1, 2, 4, 7 is correct. So where is it? A bar, B bar, C. This is 1. 2 is over here. Okay. 4 is over here and 7 is over here. Option A is correct. Either you can solve it this way, or then you have the long method. So how can you do that? Either you use this method. First you calculate the output of this, so that you will be calculating A XOR B. Then again using this you will be calculating X. So how can you do that? First calculate, let us calculate this as, let me write it as Y. So first calculate Y. So that will be what? A B complement dot 1 plus A complement B dot 1. So this is A XOR B. So Y is A XOR B. So this Y is over here. So once again you can see Y complement C dot 1 plus Y C complement dot 1. This is equal to X. So put this, this will be A complement, A XOR B complement dot C plus A XOR B complement C. So you can see what this is, basically A XOR B XOR C. So after wasting few minutes, you will be getting option A once again. So now this is the second last question that we have. Tell me very quickly what will be your answer. Very quickly. I want answer for this question. Next question, I will give it as homework. This is very good question and I want you to think about it. Don't copy it from somewhere. Okay. Don't look for solutions. Okay. So this question we will solve in the next class. This is very good concept. But I want you to solve this question right now. Answers D. Piyush is telling D. So look over here. A 2 to 1 digital multiplexer having a switching delay of 1 microsecond is connected as shown in figure. Now what is the switching delay? I will tell. The output of the multiplexer is tied to its own select input S. The input which gets selected when S equal to 0 is tied to 1 and the input that goes selected when S equal to 1 is tied to 0. The output V0 will be. Okay, fine. Case 1. Case 1. When S is equal to 0. When S is equal to 0, this line S0, because this is S0, so this input line will be connected to V0. Now you can see V0 is equal to what? V0 is equal to 1. And this V0 is shorted to S. So S becomes 1. But here you can see there is a switching delay of 1 microsecond. The moment this output goes to 1, after 1 microsecond, see, at 0th microsecond, I am talking about this circuit starts at 0 microsecond. At 0 microsecond, what happens? This S is equal to 0, okay? S equal to 0. So when this S is equal to 0, immediately your V0 will be 1 at 0th microsecond, okay? So this is your flow diagram. So at 0th microsecond, this is your 1. Now, immediately even this will be 1. But switching will take place after 1 microsecond. So case 2, that is S equal to 1, it will happen after 1 microsecond. See, immediately this output is 1 and this S line, it is 1 after 1 microsecond because it is given in the question there is 1 switching delay. Okay. So after 1 microsecond, till that time output is 1. So after 1 microsecond, what happens? after 1 microsecond, what happens? Your S becomes 1. So the moment it becomes 1, so this will be now connected, because S equal to 1 is this line. So this will be connected to V naught. And the moment this happens, you can see the input to S1 line is what? It is 0. So V naught becomes 0. So this will immediately become 0, but as switching delay is 1 second, so this 0 will be executed at t equal to 2 microsecond. So after 2 microsecond, again this S will become 0, 1 will be getting connected, and this cycle will go on and on. So output, if you see, from 0 to, means if I draw the number line, so this is your t, this is 0 microsecond, this is 1, this is 2, this is 3, so on and so forth. So from 0 to 1 microsecond, your output is equal to 1. Why? Due to this switching, because switching takes place after 1 microsecond. So till that point, 0 is already holded. After 1 microsecond, this will become 1, and when it becomes 1, so this S1 means S1 will be connected to V naught, and input to S1 is what? It is 0. So after 1 microsecond, this will become 0, and it will stay at 0 till 2 microsecond. Again, this will become 1, and this cycle will go on. So the output V naught will be what? They are asking 0, 1, pulse train of frequency 0.5 megahertz, pulse train of frequency 1 megahertz. So time period, you can see it is 2 microsecond. So frequency will be what? 1 divided by 2. So that is 0.5 megahertz. Option C is your correct answer. Why, Piyush, option D you have marked? Why option D? Why option D? Option C is your correct. Pulse train of frequency 0.5 megahertz. I did mistake in calculating time period. Why did you take it as 1 microsecond? So don't do like this, okay? So this question, this one, this will be your homework, okay? I will send you the slide, means I will upload it, okay? And I will even post it in the group that I have uploaded the slide, okay? So you can get it over there. So within 5 minutes, I will upload it, okay? So I will upload it in your drive, and you can access it from there, okay? So with this, we are ending today's session. In your